Hello class, welcome to Algebra Concepts Lesson 3.2, which is all about functions. By the end of this lesson, you should be able to determine whether a relation is a function and evaluate functions, which are written in function notation for the given values. Okay, so let's talk about some vocab first. We are talking about a function. First of all, that's the name of the section. So a function is a relationship between input and output. In a function, there is exactly one output for each input. Okay, so just so you guys know, input refers to an x value. Output refers to what we usually call y values, okay? And the next thing for vocab is the vertical line test. So if a vertical line intersects a graph more than once, a graph is not a function. So let's remember that vertical means the straight up and down lines. So if you're given a graph, the way that you can tell pretty easily if it's a function is by drawing straight lines through the graph, and if it only hits the graph once, so in this case our graph is blue, it's only hitting once there. I know my lines aren't perfectly straight up and down, but you get the point. It only hits it once each time I draw a line. Now if I look at this next one, notice it hits twice right here, or it hits twice right here. So this is not a function. So yes, no. And then if we look here, if I draw straight lines, this part right here, the axis, is where it gets a little tricky. And the reason it gets a little tricky is because you can see that there's a point here, and then there's an open circle right here. Okay, so even though some of us might think that this is going through the line twice because it hits here and here, this open circle doesn't actually count. So therefore, this is still a function because when I draw, I'll try to draw straight down that line, it isn't going to hit more than once, okay? So this is a function. All right. Then in the background, you might hear a puppy whining. He's upset that I'm not giving him attention right now. So sorry if that's distracting. All right. Let's jump into our first example, identifying functions. So we're going to determine if each relation is a function, and we're going to explain. So remember, we said a function is anything with exactly one input, or is a relation that has one output for every input. Okay, so basically what that means is when you look at a table, your x values, your x's should never repeat. Okay, your x's should never repeat. So here I see I have a 2, here I see I have a 2. So this tells me right away this might not be a function. So then you want to look and see, are these numbers exactly the same? Like, did the same point just get listed twice? That rarely happens, but sometimes it does. Since these are two different numbers, it's 3 and a -3, those are not the same, so this is not a function. Okay, and it's not a function because we have the number 2 appear twice for x. Then for our graph, if we do our vertical line test, you can see it fails because it hits more than once. So this is not a function because it failed the vertical line test. And you can abbreviate vertical line test to VLT, just so you know. All right, now let's look at the mapping. So in a mapping, in order to tell if it's a function, you need to have each of these numbers can only have one line going from it. So like this 4 only has one line. This -2 only has one line. This 2 only has one line. This 5 only has one line. So this is a function. Some people get confused because this 3 has 2 arrows pointing at it, so they say it's not a function. But really, the range doesn't impact the function, like whether it's a function. What impacts a function is the domain, the x value. All right, so then with that in mind, let's look at points. So when you're looking at points, the way that you can tell if it's a function is, again, kind of like a table. You look, is there a value that repeats? So I have a 2, a 4, an 8, and a 4. So I see, hey, those both repeated, so this is not a function. Okay. Now, what I want you to do is I want you to look at these 3 options, the table, the points, and the mapping, and I want you to determine which of these 3, there could be multiple, there could be none, which of them are functions, and then go ahead and select the correct answer. Good luck. All right, for this one, hopefully you figured out that the mapping was the only one that was a function because it has exactly 1 output for every input. The table had 2 zeros in the x column, and the points had 2 negative 2s in the x value for x values. All right, now let's talk about analyzing data. So 5 schools are competing in the long jump portion of a track meet. The distance of the players with the best jump on each team are as follows. Team 1 has 20.6 feet, Team 2, 21.5 feet, Team 3, 20.9 feet, Team 4, 19.4 feet, and Team 5, 20.2 feet. So step 1, let's practice making a table. So Team 1 is going to be 20.6 feet, Team 2 is 21.5 feet, Team 3, 20.9 feet, Team 4, 19.4 feet, and Team 5 was 20.2 feet. All right, then we want to determine the domain and range. So our domain is usually when you're looking at a table that goes left to right like this, your domain's the top line. That's your x value. So it's the team. So in this case, that would be 1, 2, 3, 4, and 5. Then for the range, we are looking at these numbers. And remember, we try to list things in order least to greatest. So my smallest number is 19.4. The next one's 20.2, then 20.6, then 20.9, and then 21.5. So that's how I list my domain and range. And then part C, I determine whether this is a function. Well, I don't have any x values that are repeating, so yes, this is a function. All right, now I want you to read this problem and determine if the relation's a function. Good luck. For this problem, hopefully you figured out that letter A is the correct answer because each person can only be one height. It's not like a person could be 2 different heights. So that is why it would be letter A. It is a function. Moving on to our next vocabulary term, we're going to talk about something called function notation. So all that function notation is it's a way of writing an equation where you replace the y. So you can see you replace the y with f of x. So this f represents the word function. And then the way we read it is f of x. And this f, that could be g of x, it could be h of x. So different variables get used other than the f. But f is the most common, and then g and h are the other 2 really common variables to be used to represent functions. Okay? So the only thing that changes with function notation is the y becomes f of x. All right, so if we are talking about finding the value for the given function, instead of saying like in the directions like x equals 4, this is a faster way of writing it. So we would just replace x with a 4. So I take my function from up here, f of x equals negative 2x plus 9. And instead of writing x, I'm going to write 4. And then negative 2 times 4 is negative 8, plus 9 is 1. So my answer would be 1. All right, then if I were to do something like this where I say f of 5 minus f of 1, that means I'm going to evaluate it once using the number 5, once using the number 1, and then I'm going to subtract those two answers together. So I'm going to say negative 2 times 5 plus 9. That's negative 2 times 5 is negative 10, plus 9 is negative 1. Then if I carry down my subtraction symbol and I do negative 2 times 1 plus 9, that's negative 2 plus 9, which is 7. So negative 1 minus 7 is negative 8. So that would be my answer. Okay, so I want you to go ahead and find the value for the given function. F of x equals negative 3x plus 2, and figure out what happens when x equals negative 4, or f of negative 4. Good luck. Okay, for this problem, hopefully you figured out that negative 3 times negative 4 is positive 12, plus 2 is 14. All right, let's try another one. I want you to figure out f of 3 minus f of 6. Good luck. All right, for this problem, hopefully you solved f of 3 and got negative 7, f of 6 got negative 16. Negative 7 minus negative 16 becomes negative 7 plus 16, which is 9. All right, and then our last one, we have f of 5 plus 8. So notice this is a little different. This 8 isn't in the parentheses with an f. So what this means is you solve the f of 5 first, and then you take that answer and you add 8. Good luck. All right, for this problem, hopefully you said negative 3 times 5 is negative 15, plus 2 is negative 13. Then you added 8 to that answer and you got negative 5. If you have questions, please be sure to reach out for some help. I'm happy to help you. Well, let's move on to the next example. Let's interpret function values. Mason works at a movie theater after school. The function g of x equals 9.25x represents the amount of money he makes before taxes for each hour that he works. Evaluate and interpret the function for each value. So letter A, g of 8. So what that means is I'm going to do 9.25 times 8. And 9.25 times 8 is 74. So this means that if Mason works 8 hours, he will make $74 before taxes. Letter B, g of 14. So that means I'm going to do 9.25 times 14, which is 129.50. So it means if Mason works for 14 hours, he makes 129.50. And then our last one, if he works 27.5 hours, then he would earn, that's 254.375. But money, we only ever care about 2 decimal places, so I need to cut it off, but I need to round. So this 5 is going to make that 7 become an 8. So it'd be 254.38. So $254.38 is how much he'll make before taxes. All right, last question is for you. A swimming pool that holds 10,000 gallons of water is being filled at a rate of 600 gallons per hour. The function h of x equals 600x represents the amount of water in the pool after x hours. Find h of 3.25. Okay, so 3.25 hours, we're going to do 600 times 3.25, which gives us 1,950. So what that would mean is after 3.25 hours, the total amount of water in the pool will be 1,950 gallons. All right, so if you have any questions about this problem or anything else from the video, please be sure to reach out for some help. I am happy to help you. I hope you have a great day.